Welcome to Unit 3, Lesson Topic 2, Solving Similar Triangles. I'm Mr. Pilarski and I'm your math teacher. Our objectives today are: I will be able to find missing measurements of similar figures. I will be able to use a scale factor to estimate lengths and distances. I will be able to apply similarity to make indirect measurements. And I will be able to use a scale drawing to estimate lengths and distances on a map. Let's get this Algebra 1 party started. Here we have some information about similar figures. Triangles ABC and triangle XYZ are similar. This means they have the same shape but a different size. Now that right there, that's the definition of similar. You might want to write that down or highlight it. This is the definition of similar, that they have the same shape but a different size. That's the definition of similar. What that means for us is that angle A is going to be congruent to angle X or equal to. Angle B is going to be congruent to angle Y, and angle C is going to be congruent or equal to angle Z. In other words, angle A and angle X are going to correspond, angle B and angle Y are going to correspond, and angle C and angle Z are going to correspond because they are congruent or equal to one another. Now here's the important part, is that the corresponding sides are proportional. We just learned how to solve problems with proportions, and similar shapes, in this case similar triangles, their sides are going to form a proportion, and it's going to be an extended proportion where side AB is the same or corresponds to or proportional with side XY, and we can write that as a ratio, AB to XY, and that's going to form a proportion when we set it equal to BC over YZ. Those sides correspond. We can write an extended proportion and add a third side here, since we have a triangle, AC over XZ. That's where we get our ratios and our proportions from. And we're going to see how to use this to first find the missing lengths of sides of similar polygons. Here we're working with similar figures in example 1T, finding the length of a side. Find the length of AB. What we're assuming here is, since we're working with similar figures, that triangle ABC is similar to triangle XYZ. And the way we could write that down would be like this, that triangle ABC is similar to, that's like a squiggly line. If you're in Spanish, a Spanish class, that'd be the tilde or the accent above the N, and then be XYZ. So what we can do here then is know that AB corresponds to XY. We can write a proportion or a ratio out of that, actually, AB over XY, and that's going to be equal to the other pair of corresponding sides, BC over YZ. Now we substitute our numbers in with the substitution property of equality, and AB is what we're solving for, so I'll just leave that as AB. I can leave that as a variable. For XY, I substitute 8 inches. For the BC, I substitute 9 inches. And for the YZ, I substitute 6 inches. Now it's a matter of solving the proportion, and that's just using cross products. Here we go, 6 times AB to give 6AB, and that's equal to 8 times 9, which of course gives 72. Divide each side by 6. The length of AB is going to be equal to 12 inches, because 72 divided by 6 is 12. And I put my units on there. So the length of AB is 12 inches. Here we're going to be talking about some indirect measurement. Example 3T, applying similarity. A flagpole casts a shadow of 75 feet long. A 6-foot man casts a shadow 4 feet long. How tall is the flagpole? Well, let's take a look at what we can do here. Now let's take a look at what we're given. What we're given here is that a flagpole casts a shadow that's 75 feet long. Then a 6-foot tall man casts a shadow 4 feet long. We're also told that the man is 6 foot tall, and we're asked to find how tall is the flagpole. We're given 3 numbers, and we have to find the 4th. So we're going to use a proportion, and the proportion we're going to use is going to come from the idea of similar triangles. What we have to find is this measurement right here, how tall the flagpole is, that blue line. That's what we have to find, and we're told that the flagpole casts a shadow that's 75 feet long. Now look what happens here. If we connect the top of the flagpole with the end of the shadow, what we have is a right triangle. We're going to assume that the flagpole is perpendicular to the ground, which it should be built to be that way. So this is a right triangle. And since the shadow is formed by the same sun, if you will, if I draw a picture of a man here, and it's a simple stick figure, we know that man, he's 6 foot tall, and he casts a shadow that's 4 feet long. If we connect the top of that man's head with his shadow, end of his shadow, what we have is a similar right triangle. We have to solve for this value here, x. So the way we do that from the previous example is we're going to go 6 over x is equal to 4 over 75, where x is the length of the flagpole, or the height of the flagpole. So when we cross multiply, 75 times 6 is 450. X times 4 is 4x. Of course, we're going to divide both sides by 4. And what that gives us is x is equal to 112.5 feet. So the flagpole is about 113 feet tall. Exactly, it's 112.5 feet. Here we talk about more indirect measurement. We're going to use more proportion to solve. A scale drawing is an enlargement or a reduced drawing that is similar to an actual object or place. Floor plans, blueprints, and maps are all examples of scale drawings. The ratio of the distance in the drawing to the corresponding actual distance is the scale of the drawing. Here we see this word corresponding again. The idea of a scale drawing is used or similar to the idea of similar figures. In fact, similar figures are behind the idea of scale drawings. We can see here the ratio or the rate is the measurement in the drawing over the measurement in the actual figure. That's the scale. So the drawing over the actual. In example 4T, we're going to be working with indirect measurement to find distances on a map. The scale of a map is 1 inch to 10 miles. The map distance from Valkyria to Gifford is 2.5 inches. Approximately how far is the actual distance? Well, we just saw in the previous slide that scale is defined as the drawing distance over the actual distance. So what we're going to do is we're going to set up a proportion. And we're told right here in this first sentence that the scale of the map is 1 inch to 10 miles. So on the drawing we have 1 inch and the actual distance is 10 miles. On the other side of our proportion, we're going to fill in this. the map distance, and it tells us that the map distance is 2.25 inches. We have to find how many miles. So when we solve this proportion, we multiply our cross products, x times 1, which is real easy, that's just x. And that's equal to 10 times 2.25, and of course that's 22.5. That'd be miles. The units on that would be miles. Since it says approximately, we could say it's about 23 miles. And I guess technically you could say it's about 20 miles. That number would round to 22. But that's how you use scale to find the distance on a map. In example 5T, we're going to continue our work with indirect measurement and solve a multi-step problem finding distances on a map. Now, this problem can be done in 2 steps or it can be done in 3 steps. I'm going to show you how to do it in 2. Use the scale and map measurements to find the actual distance from Dobville to Podunk through Green. Key thing here is we want to go from Dobville to Podunk, but we have to go through Green. So we have to go up here, and then we can go down here. Now, the map distance to go from Podunk, or from Dobville to Podunk through Green, is 2.25 inches from Dobville to Green, and then it's 2.75 inches from Green to Podunk. So we have to find a total here, and the total map distance, it's an A right there, total map distance, is going to be 2.25. I keep saying 2.5, 2.75. We're going to add those together. That should be some pretty easy addition. 2.25 and 2.75, that gives us a total of 5. Quarter and 75 is $1, and carry the 1. 2 and 2 is 4, plus 1 is 5. So that'd be 5 inches. So we're going to set up and solve a proportion now. And we're going to use this scale right here. A lot of students miss that scale sitting right there on the map. The scale on a regular map is usually somewhere. In the previous problem, it was written right into the problem, but on a map, it's there. So here's the scale. And what that says is we have 1 inch to 15 miles. And that's going to be equal to 5 inches to how many miles? X miles. So when we solve this, x times 1 is x, and 15 times 5, of course, that's 75. So the actual distance from Dobville to Podunk, but going through Green, is 75 miles.